Oh man, I didn't have my mic on. I'm sorry. I'm going to stop it and start it again because this is going to be recorded, and that first part I'm like going on forever. So folks, I'll be right back. I'm going to stop it and start it again. Come on, don't bomb. Okay. Okay. That's really weird. So I apologize. I think this is not going to be great for recording because I had my microphone off and I was talking away, and then I tried to stop it and start it again, but it seems like it kept going. So I appreciate you guys hanging in there. Long story. I'm on a different computer, even though it looks all the same to you guys. But as I was saying, I'm going to be talking a little bit about today about pretty much my philosophy of science, because I've been getting a lot of subscribers from some channels that have been talking about me, and that's cool because actually, even if it's not flattering, people do come by and they start looking at what we're talking about, and they get more and more subscribers. And the last day I've got almost 8, 9, 10 subscribers per day. So I appreciate everybody who is new to the channel, and I apologize for this streaming video part because again I had my microphone. It's a nice microphone. Keep it off camera, don't need it because my voice projects. And so anyways, yeah, I've been getting more subscribers in the last few days because of the talking about my channel. Some criticisms, but I don't know if they're much founded, but I think most important is it made me start thinking about why, people may or may not like my channel. And I think part of it is because I talk with a lot of confidence, but it's not because I how do you say, know more than someone, or it's not because I have more answers. Well, I do a lot of times have more answers, but they're not always my answers. I've been around the people outside the mainstream for so long that, in fact, you learn a lot. You get to understand how to answer these questions. I've been going to conferences almost every year for 96, well, over 20 years now. So you get to, I started to accumulate the ability to answer questions from people. In fact, there's one guy here where I live, and he, every time I showed up at a party, he just sits and asks me science questions all day. And people enjoy it, I guess, because I have some answers. But I think, I'm going to be making a video on my philosophy, but I'm going to talk a little bit about that. And I think part of my philosophy is, and it took me a little while, especially with this channel, it helped out a lot, and that was basically, I support everybody who's trying to come up with something different. even if I don't agree with that model at all, even if I think the person's got a lot to learn, in the sense of they're new to doing these new models. They'll call, for instance, energy as a something real. You can talk about it, but it's a concept. And anyways, hey, there we go. We got some people. I've got the chat back now. It says audio isn't working for me. Don't hear anything. Yeah, that was pretty stupid. I apologize for that. No audio. Yeah. So I probably lost some people because of that. And technical issues. I think I had up to 6 people, but I think this is a little bit delayed because what I see on my side here tells me, yeah. But again, I think when I looked at specifically one person who's been, I'm not going to give the channel name because I'm not into getting people publicity, especially if, I don't want to, I think Lisa knows who's this person, but, Lisa, this person will make videos. I think 1 or 2, very puts a name, stupid name with dissident, like, dissident, stupid, or stupid dissident or something like that. But I have no qualms about that. I have zero response to that. Obviously, if I felt bad about it, I would be worried about it and responding to it. I'm not. But it makes me think about what's really going on in the dissident world and why other people do this. Why do other people attack other people who are obvious? I mean, I do have my own model with my father, but I'm the first to say it's really interesting and we're going to continue to work with it. But is it the right answer? We don't know. Is ether the right answer? We don't know. Is the lattice theory right? Don't know. Is the standard theory right? Not likely, because it's got so many problems. But so I'm not out there to say to anybody, okay, what I'm doing is right. Other people who have their own theory are married to it. They think only about that, and that's okay because that's what they're doing. But they don't accept other people's, and they don't accept that theirs could be totally wrong. Just like my father and I might think. My father and I think at times it's all totally wrong, but then at times it's holding up, meaning we can't break it yet. But again, we're in this love-hate relationship with it all the time. But you hear me say all the time, my father and I are our worst critics when it comes to the model that we're looking at. And that kind of engineering attitude is really, really important. And first of all, instead of people who have other channels, who are outside the mainstream, who have other channels, instead of bashing people who are trying new things, what you end up having is you're against the entire world. We already have a big enough fight to try to fight big science, and that's a huge fight. But for us to sit there and also fight each other, and it happens. There is. We have at our conferences almost knockdown, dragged out fights. I mean, physical, aggression at times. And I don't have a problem in the sense that I don't sit there and criticize people because I'm extremely passionate about it. But it's really hard for people, and I'm trying to change the minds of those people who seem changeable, to say, look, stop bashing other people. Just stop glorifying your ideas and your models, and you don't even have to have a model. And start looking at other people and their points of view and try to understand why they're doing it. Now, if once you do that, you can help them, or you can decide for yourself, like I have, that ether, for instance, is not something that I will pursue. It's something that I think has, inherent problems, but people continue to work on it, and I'll continue to listen to it, and I'll continue to help them with it in the logical places that I can. Glenn Borchert's closest to ours because of infinity. But again, the whole thing is it's sort of, it's sad to see, because one of my missions within our organization is to get people to accept each other's work and understand we're in model revolution. Again, I keep saying this, but I have a lot of time off. My last day of work is Monday, so I've got through the year and through the new year. Part of those days I'm going to be working on the Science Woke website to get things up to hopefully to a place where we can launch it. I'm not sure we'll get it in that time, but at least I don't know. I'm going to try to get it to that point. And I think what's really important is that I spend my time within the organization trying to get people with the attitude, let's support each other. If a person is outside the mainstream and a person has their theory and a person has their model and they're trying their best to make that work, then do it. But we need to support each other. And we often tear each other down. We'll say, we had one guy in our group, literally, he's from Holland, send an email out. He published in our proceedings, got the proceedings mailed to him, and then he basically sent an email saying, people are crazy. I don't want to be part of this organization, and got out. Why is that? Well, that's because he believes he is right. There are people who are dissidents who absolutely believe they found it, they found the answer. And I have an answer back to those people, and that answer back to these people is pretty simple, and that is, while you are defending your stuff, while you are fighting others and telling people how bad their stuff is and wasting time on that, someone's going to look at your work, take some inspiration from it, use it, and make a better model. And I tell people that all the time. And that's what happens. That's what happened with my father and I. We've taken pieces from 3 people, and we've liked the basics of those things, and they've been put together with some of our own insights. And people, if people like it, if people sort of begin to understand it, maybe people get to use it, they're going to basically come up to us someday and say, you stole our idea. Well, I didn't steal the idea. When infinity, for instance, it wasn't my idea. That was Glenn Borchert's. He was the one who put that out there. We have people, Deneau effect. Yonel Deneau and Glenn Borchert are etherists, and I'm not. And then we have other people that have worked, and Dr. Karazani. He's probably closest to, if you put the infinity together with Karazani, he's probably the closest to what my father and I are doing. But again, folks, it's just let's take our time to cooperate and support each other. My goodness, we're fighting a huge battle out there. Big science is big problems. Not necessarily they have big money, but I mean, you have science evangelists, just like we have people today who are on the news, who sit in front of the camera and they read the stories that they're given. The stories are crafted to sell a narrative that the rich people, the people who control the world, want. You can hear videos. You can go on YouTube and find videos that are actually, news stations literally reading the same thing. It used to be 50 independent news organizations, so you had a lot of competition. Now you have 6, and they control everything. If you watch even news from different countries, England and the United States, I watch Brazilian TV, you see a lot of the same narratives coming over. And the same thing happens in science. So what you have are a bunch of people who want to be famous because they want to be on TV and they want to talk about the latest and the greatest that's happening from particle physics and cosmology. And those things are, parroted, basically, as Dr. Alexander Unsker from Germany says. He says they're parroting. They're just basically saying that. But again, it made me think of why is this different? I know Lisa has said many times that, hey, David's cool because he accepts other people's theories. Well, guess what? We all should. If there's a person, we all have to doubt it right now because since Newton and his peers and the people right after him all the way through the 19th century were looking for ether and gravity and gravitons, and they even use the gravitons today. And then, yeah, we've got lost. Relativity got us off track. All the invented particles were totally off track. The Standard Model, you can pretty much, in my opinion and many people's opinion outside the mainstream, you can throw it away. And so where are we left? Well, we're left to trying to come up with some models. And where do those models come from? From decades and decades of work by really brilliant people looking at what goes wrong. And that's, where things come. That's where my confidence comes when I talk about these things. I will tell you, how much confidence do I have that my model and my father's model is right? I don't know. I don't even know that answer. Is it good? Yeah. Is it better than the Standard Model? Absolutely. I mean, we don't have any variables at all. We don't have constants. Those things, constants, are silly. They're really basically crutches, mathematical crutches. But is ether right? It could be. Most people are etherists. And then we have people in our group that leave the group because there are etherists even out there, and they subscribe to the old adage about why ether was thrown away. So, anyways, it really does come down to all of us, all my subscribers, everybody. I urge you to sit back, relax a little bit more, realize that there isn't a couple of things. The Standard Model is broken. This is, if you ask Dr. Alexander Unziger, who talks with the theoretical physicists who win Nobel Prizes, you can go to the Machian and subscribe to his channel, and you will see his interviews with some Nobel Prize winning people who sort of get really frustrated with him. I did a video on that. Take a look at that as well. I can't remember, David Wood, I don't remember, but he was, those are extreme minority. The number of people who really go along with that is very small, and the people who are vocal on the internet about it, or who go to the book presentations of, like this book, which I saw Physics on the Fringe by Margaret Wortham. Who goes to those are a bunch of intellects. They're not even critical thinkers. They're intellects. Intellects are people, I have come up with this to sort of distinguish it, to use my vocabulary. Intellects are people who claim to be smart. They want to be the latest, they know the latest of the latest. Oh, did you know? I'll give you what an intellect would say today. Oh, didn't you know that the Large Hadron Collider is being shut down for 2 years so they can even make it bigger? And this is, of course, predictable by a lot of people, but that's what they care about. Oh, if you went, well, I don't subscribe to all that stuff in the way they find particles. It's a joke. It's an absolute joke. It's a travesty in logic and engineering and in process, even in process, an engineering process. They would receive a failing grade. They would be shut down by all the engineers. If you got engineers from NASA or SpaceX or any place where they're really working on real things, they shoot it down. So even though we are, that's why I think this is a majority. I think this channel will continue to grow. It's like I said, in the last 3 or 4 days, thanks to people bashing me, they come by and they go, oh, wait, this guy's cool. And the reason is because I am open-minded to trying to find truth. And right now, we don't know which model is going to win out. Ether models continue to bump into the same problems. So, let me take a look at some of the comments here. I think it's interesting that different models can work. I've been under the weather, so okay. I agree, Dave. Look at all sorts of different theories, etc., toward the lean toward the electric universe. But that's very interesting. It turns out, I'll tell you something about that, Lisa. Do you ever try to attempt to understand a particle model and find that you're not grasping it? Oh, particular model. That's a good question. Boy, Tom. Yeah, do you ever try to attempt to understand a particular model? Sometimes I do. And I think most of the time the problem isn't me being able to understand it, because most of the time I get it because I'm sort of a big picture person. I'm a systems person. I love systems. I'm less detailed and more big picture picture oriented. But that's a good question. The answer isn't yes or no. The answer is it does take me sometimes to understand it. But then when I start to question because I don't understand certain things, it's because the models have illogical parts to them. And so I'll ask them, oh, well, how does this happen? I know you're saying this, but what's the justification for this? And the person will either have to admit, okay, that's an assumption, meaning it's just the way it is. In your model, in theory, it's perfectly reasonable for you to have assumptions. That's what we have. And what are assumptions? Well, you're supposed to, people say, making an ass out of you and me. Well, it's not necessarily that, but it's really assumptions in science are those things that you postulate as true, and you're not going to, or you can't say why. And so when I'm looking and I'm trying to understand a new model, like Jeff Yee's model, the energy wave theory, so go to energywavetheory.org or com, can't remember which, but look him up, Jeff Yee, Y-E-E. When I was first understanding his what he was doing, I got it pretty quickly because it involves some pretty simple math, pretty much just algebra, where he's equating the wave equation with the energy mass equivalence, and basically introducing that into the system, and therefore being able to simplify it, and I get the picture. But he has, of course, a very clear picture of describing his. Whereas with other people, there's so many vagaries that when when I listen to it, I say, okay, but what about this? How do you? And they go, well, they either skip it or they ignore it, or they argue with it, or they start defending it emotionally. But pretty much I'll understand it, but most of the time the not understanding is more not getting answers to problems with the theory. Like infinity. You have waves in something. What's it waving in? Is it ether? Okay, it's ether. Is there anything below ether? So those kinds of questions. But they're very good. It's especially hard for people without formal physics training. Yeah. Well, I don't think so. Most of my questions aren't mathematical. Most of my questions are fundamental, like, do you have an ultimate particle? Do you believe in the infinity? Are you an ether theory? If you are, how do you describe lasers? If you do have ether theory, but when I'm understanding people's theory, I'm totally fascinated by it. In Margaret Wortham's book, I wonder if I have that. Come on, do I? I don't know. I'll give you one here. I think I did a review on this one. Relativity really equals mc squared. Enter the ping theory. I did this very small book by an author. Again, you can look that up. And he does his ping theory. And what I found here is very interesting, and I try to understand it. Again, the idea is to try to understand where the person's coming from. And in this case, I would say it's really interesting. He solves things at higher levels, but when you put it down to a more detailed level, and you really, there are a lot of fundamental things that if he were to come to our group and be dealing with a lot of us who have dealt with lots of people and lots of theories, we'd have questions for those, and they'd have to be answered for us to be able to go forward with that. So that's something. Says Jim. He says, Physiology. I'm an undergrad, just starting in physics major. I'm interested in condensed matter physics, partly because that seems to be less. I love it. Fossilology. I love that. That's a BS involved. Is this true concerning condensed matter? I guess you're asking, is it the case that condensed matter isn't going to I don't know a whole lot about it, but let me look it up. I have no problem of doing that. And let me see here. Just hold on. If I understand it, my guess is the answer to your question, yes, it is a real science. Let me, physics. Let me look this up. If I do see something interesting, I'll show you guys. This is fun. How does Dave go and do these things? Well, I do this a lot, and again, because I've been hanging out with these really brilliant people. Let's see. Is the field of physics what it deals with macroscopic and microscopic properties of matter. Condensed matter physics. Okay. Let me see if I can get this on the screen here. I'll sort of make it smaller. Oh, I guess Wikipedia doesn't like to get smaller. No, I do not want to donate. Oh, look at this. This is fun. Here's some politics involved. Here we go. I'm looking at condensed matter, but at the top is a 2RL resource. This is where I can get straight out of the point. This Friday, humbly defend independence. Our donations are averaging $16.36. I think this is like from the Bernie Sanders idea. Maybe later. So no, I don't want to do this. And let's see, condensed matter. This is good. Can I get it? There you go. Let me tell you why I don't donate to Wikipedia. It's because Wikipedia is consensus. I'm going to get to the condensed matter problem here. Wikipedia is consensus. We have our own Wikipedia, exact same software because it's open source. And the reason we have ours because anytime we go in and we put anything expanding Earth and put any alternatives to any theory, it's looked at as pseudoscience, and it's not accepted, therefore it's pseudoscience. And that's ridiculous. So I do not like Wikipedia for that. I think it's flawed, fundamentally flawed. Wikipedia should allow us to have alternative theories that would make the world go around and move quicker in the area of science, but they don't. So I don't donate to them because I have tried. I tried to even put James. Listen how crazy this. Expanding Earth, right? That's something that's not in the mainstream, but they put down for some reason. I don't know. I think it's because Samuel Warren Carey, who is very greatly respected in plate tectonics, his craziness of accepting expanding Earth theory allowed him to at least get into Wikipedia and not be pseudoscience. But when I go to put Dr. James Maxwell, they remove it. And Dr. James Maxwell was his protege, Dr. Samuel Warren's his protege, and he is the #1 person in expanding Earth. He's got a degree. He's got a doctoral degree. He's written books on it. In fact, I'm getting his new book. He's sending it to me now. Why do they take that out? It's absolutely nuts. I mean, they have the page. You'd think they'd put the #1 person there. Well, they don't do that because there are people who are censoring. It doesn't matter what you call it. So I will not contribute to Wikipedia. Sorry. All right. So condensed matter is field. It's the field in physics that deals with macroscopic and microscopic. Oh no. Everybody's going to yawn. Sorry about that. Physical properties of matter. In particular, it is concerned with the condensed phases that appears when the number of constituents in a system is extremely large and the interactions is extremely strong. The most familiar examples of condensed phases are solids, liquids, and arise from electromagnetic forces between atoms. Condensed matter physics seek to understand the behavior of these phases under physical laws. In particular, they include laws of quantum mechanics, electromagnetism, and statistical mechanics. Well, I would imagine there's parts of this that are less theoretical and less crazy than others. The most familiar condensed phases of solids and liquids were more exotic. Condensed phases include superconducting. Yeah, no, these are people. Let me just say this. This is the way I would explain this. The people doing this are doing real things, and they're doing real things for the world. Go into it. Go into it. if you're going to go, if you go into, I don't think this field is sustained by people talking about crazy theoretical things like quantum mechanics in general. The way they talk about quantum mechanics, that's crazy, where you have millions of parallel universes, and the reason we're all in the one we're is a collective consciousness that makes the decisions because of things. I don't think they're talking about that. Condensed matter physics, I think, is a useful endeavor for mankind that creates things that are very interesting. Now, the models, I think, probably you're going to get a fringe group in that area, maybe even at conferences that will have conferences on condensed matter physics. You go to that conference, you're going to find some people who are theoretical, and they're going to talk about some crazy things. The downfall of all this is the same answer I give for almost everything. They don't have a physical model. That's why people outside the mainstream, like ourselves, critical thinkers, people who are more science woke and realize this, we are working on models. My dad and I have one rule: everything has to be physical. If it's a force, if it's a magnetic force, electromagnetic force, if it's a gravity force, it is caused by some mass. It's going to be small, super small. It'll be not infinitely small, but super, super small. But it's got to be caused. There's nothing magical. There's no fields out there that are magical. Everything has to be physical. But when you talk to people who are probably in this area who are more theoretical, they're going to say, well, we don't know yet. We're still trying to find out. It's crazy. But usually what you'll hear from people in the quantum mechanics side, and even in like the science evangelists like Neil deGrasse Tyson, Bill Nye the Science Guy, and that I can never remember. I think it's a Japanese guy. Looks like Einstein. All those people are going to say, well, the universe is crazier and stranger than we think. No. The universe isn't strange. Our theories, our interpretations of the universe are strange. The idea that this whole double slit experiment, that they can't even understand the simplest thing, that is when you turn on a detector to try to find out which slit an electron or a photon went through, it's going to affect it. It'd be like saying, I'm going to take a candle and I'm going to get close to something that's an experiment. You got heat, you got convection, you got all kinds of stuff. It's going to affect things. But people are going to make weird and crazy. The universe is not weird and crazy and unintelligible. Our interpretations of the universe are. That's even better than the models and theories. I have to write that one down. So my answer to this is these people do real stuff. A lot of it you talk about, they're working with materials, superconductivity, they're trying to nanotechnology. So yeah, it's pretty cool. So experimental stuff, very worthwhile. You can see even here, very variety of topics in physics. This is crystallography, metallurgy, elasticity, magnetism, etc. So there's quite a lot of stuff there that, if you're going into that, that's pretty cool. Let's see here. Tyler, often opposite. Preconceived ideas from formal training can keep your mind closed to new ideas. Whoa, is that true? And, I always tell you, if you haven't heard this story, nerds like to be loved. Nerds are people who get picked on in school, and by the time they get older, they want to become thought of as super brains. The way I was talking about, they've got this super brain. It's bigger than ours. And so they have some wisdom and calculating power that no one else has, which is not true. Genius is not, the idea, they can understand everything in the universe. You got to study that, and the only way you can do that because it's complicated. No, it's all baloney. Do you accept the mainstream model of physics, strong, weak force, minimum gravity, etc.? I don't know if you answered that. Fractal universe, 5D space-time, frequency of cycles in dimensional scale. Not sure what that you're trying to say there. Theory of scale relativity, interesting ideas here. Well, I'll take a look at that. Dave, I think it's all energy, vibrations, waves in the ether across between Jeff. We no such thing as a particle, just standing wave in ether. Yeah, Roddick Cerny. Yeah, if you're an etherist, I understand Jeff Yee's model. It's a standing wave. Particles are standing waves. Stable structures in an ether. Most ether theories, except for Glenn Borchert, suffers from the problem of magical particle syndrome, they think it's, how can I put it? Ether exists, in my opinion, because of really one reason. People want to explain light in a physical way. And therein lies, in my opinion, the bias. We have a bias emotionally to think that light is a wave in some medium. The problem with that is if you have the universe, which is filled with really three basic things that we see conventionally are common sense. Gravity, we know about gravity all the time. We drop stuff, right? Every human on Earth knows about gravity. They have an intuitive feel for it. Magnetic fields, so when people play with the magnets, they get this intuitive feel that there's this force, very strong force going on there. And then you have light. We know that we have light. We have light, and we can say, oh, this has a wavelength of this, blue and red and all the spectrum. So if you are trying to solve the light problem, this is something I haven't actually said, and that is solving only one part of the universe. And then what happens is etherists want to stick everything else into it. So you're seduced by this idea, what light, oh my gosh, it's so important. We see things, our vision is so important. Light, light, light. And then we come up with ether. And then we come and, how do we fit gravity into it? How do we fit magnetism into it? And that's where you get Lionel Deneu's underwater experiments. Oh, it's ether, it's the flow in ether that creates magnetic fields and positive and negative and that kind of stuff. So you have the idea of ether, but it doesn't solve the rest of the problems. If you're coming up with a model, you got to explain everything. You've got to explain lasers. You've got to explain how can you have something that can bump for 10 billion years, travel 10 billion years in 10 billion light years, bumping against each other and then reaching your eye with that and still being there. If you look at mainstream physics, of course, they will dismiss ether for, like the one guy from the Netherlands. He dismissed it by quoting the elasticity factor that ether particles would have to have in order to make light transmit. What does that all mean? If I have a bunch of billiard balls floating in the universe, and I'm going to say that light is coming from the sun, is me throwing one billiard ball and it smashes into other billiard balls and eventually gets to me. Well, the elasticity of that kind of medium has to be really high, according to them. My answer to those people, like this guy from Holland, is that no, modern etherists and different ways of looking at it, you can come up. Ether is an ample field, ample and open problem. We have literally 20 people working on it with 20 different ideas of it. And again, it's a solution for light. That's why ether was invented. Gravitons were a solution for gravity. So my dad was in the graviton area. The difference was he came up with a perfectly simple way to represent waves with particles. Now, to me, that ended up, and then you put that with Lionel Deneu, there you go. Particles can describe everything. Waves can't describe everything. They can't describe a laser light that, yes, it spreads out a little bit, but it goes a long, 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 long way. It also, how does it branch out? Why does it happen? Why does the rainbow occur when you shove light through a prism? So so you have to have transverse waves, they call them. Well, people ignore these problems, or they think they solve them and they don't. So no matter what happens with ether, the number one thing that I really have been thinking about in the last couple weeks, literally with ether, is that it is a solution for light. Okay? It isn't a solution for gravity. It isn't a solution for magnetics, although, Denis Deneuve has fixed that and given us a model. So anyways, that's my answer to that. Let me read here. I'm sorry. I'm going through the comments. Are radio waves particles if light is? Are radio waves particles if light is? Yeah, absolutely, of course. If you subscribe to the particle model, all electromagnetic waves. Here's something really interesting that I just came up with literally this week with our model, and that is, in our model, random particles going in all directions, just like the air. We call that a gravitational field. That gravitational field is at this level. The gravitational field can be at the lower level for things going around a nucleon, a nucleus of an atom. And then I came up with this other thing. The electrical part of our model is ether flow. Ether flow. It's not ether. Particle flow. So particles that flow together is what we call the electrical part of the universe. And that's where you get the Deneuve effect. So that's what our model is. And we don't have this problem of gravity, or is it wave, is it a particle? In our model, waves cannot be anything less than multiple particles. You can never have a wave with one particle. Wave has to come in multiple particles, and really, to be really useful, lots. You can't be like 10. It doesn't affect that much. Waves have to have a multiple part, but that's our model. Right or wrong. You probably need to watch more of Ken Wheeler's stuff. He focuses on magnetism, not light. That's fine. Magnetism and light are, ether can describe both of those. I agree. Deneuve, like I said, proves it, but shows that it can. Ken states a magnet creates the ether. I'll be honest with you, that statement is really vague. And even if a person sort of describes it, it's still vague. What is magnetism? I'd have to. I know Ken Wheeler. I'll look him up here. No problem. And I'm not here to defend anything. I'm just saying ether is a light theory. Ken Wheeler interview photo walk. Maybe it's the wrong one. There seems to be a lot of Ken Wheeler. Let's see if I put magnetism, I guess. Let's see. Uncovering the mysteries of magnetism. Kevin L. Wheeler. The missing secrets of magnetism. Missing secrets of magnetism is the key of life. That's one thing you're not going to hear about our theory. It's not like life-giving, life-healing. It doesn't do that. Let's see. Uncovering the mysteries. Yeah, I think I've read this at some times. If you're looking for fresh insights and the deeper understanding of life, the universe. So is this the guy? Hey, Reddick. That's really funny because people in our group who are etherists, which are most of them are etherists, and my father and I are only particle model people. We're the only one. They said, "Oh, yeah, In particles, ether, no, because in our particle we do not talk about the particles bashing into each other, doing waves. It does exist, but it's not a fundamental part of the mechanisms of the universe. So no, no, because ether is waves in a stationary, more or less stationary medium. Yes, you can have air, and air moves, and you can still have, yes, but ether is basically stationary. Our model, it's moving at sea. So to get a light waves from a star to your eye, particles travel that entire way in waves of particles. And I also figured out how they can be 5,000 kilometers apart. They don't need to be in these gigantic stuff. So one of the questions we had in our model was that. But no, very, very good. Ether are particles. Yes, they are particles, but they're not a particle model, because our light and ether's light is really different. No problem. And again, I will be the first to say, I always am looking at ether myself. I would be always the first to say that. Maybe, could be an ether. It could be. Magnetism bends light, and gravity is, and magnetism bends light, and gravity is only magnetism. Then my question to him is, what is magnetism? Because in our model, we can tell you exactly what it is physically. See, what happens here is you end up with fields that people have. It's either a magnetic field, an electric field, and then they don't tell us what that is. Oh, it's in ether? I don't know. That's the thing. It's, yeah, what's it, flowing particles? Gyromagnetic ratio of precession. Again, normally these things you'll end up getting, say, okay, you have a field or you have magnetism, and you start to understand that the person's not really clear on the model of what that is. Okay, it's not an ether, it's magnetism. What's magnetism? What is magnetism? Is it particles flowing around like Lionel Deneu's experiments support? So I'd have to find what that is. Incoherent magnetism. Okay, tell me what that is physically. Give me a description that anybody can understand. Because any model like that needs to do that. Permanent magnet is coherent. You know, it's a system. I think it's great. I applaud him and I support his work, and I think it's great that he does this. This is super. But there's a lot of vagueness here. I know there are calculations and all that, but I'm going to look at it just like any other person and say, what's that? What is that made out of? Tell me. That's one of the reasons we're working in the particle model, because we got tired of that, not answering that question. If you ask my father and I what something is, we're going to tell you exactly what it is physically and how it's made up of, and that moves. Again, I'm not here saying, oh, it's better. I'm just saying that is something that people have to do. So let me see here. I have to look at this more. Falsification of Newton's universal law of gravitation. Let's see. It says Newton's law of universal gravitation states that every point mass in the universe acts and tracks points. I guess this is for a person who never has read about anything about outside the mainstream, because this is everybody. Everybody in the mainstream, outside the mainstream, we almost all agree what this is and means. So yeah, absolutely. Its attraction is basically a calculation. G is a constant. It's a fudge factor that we use, and in fact, G changes. G is different in different parts of the universe. But yeah, that's true. Okay, that's fine. So what is he going to say? Observation of rotational spirals Okay, that's explainable by Newton. Dark matter came to, sadly, the scientific establishment deviated from the scientific method, refusing to accept the falsification of Newton's law. Blah, blah, blah. Instead, scientific establishment to keep Newton in belief system intact by mathematical invention of dark matter. Okay, let me tell you why this, in my opinion, is not a good idea, where it falls apart. My father and another person, Cameron Rigasol, both of those people have talked about and shown that the Newtonian gravitational field is not uniform, and that the spiral arms in a galaxy, here's how I can tell you that it's not. If you shoot something toward the center of the galaxy and it's near an arm, there's more mass over here, it's going to curve, right? Everyone gets that. Everybody who knows gravity, it's intuitive. It isn't a uniform thing. It's just like, if even the solar system, gravitational field isn't uniform, why do you think we send probes next to planets? So what this guy is saying is that dark matter, because we didn't falsify, no, that's one thing you can say. You can say, throw out Newton's wrong, and the reason he didn't throw out Newton is because of dark matter. No, Newton can describe, I would say no, it's there, you can describe, not dark matter, but you can describe first of all, people don't explain why there's dark matter. Dark matter exists because the calculations used by, it's unbelievable. They put a point in the middle of the galaxy, say that's what the mass of the whole galaxy, treat it like a point and uniformly, and then they say the stars on the edge are going too fast or too slow. I think it's too fast. They go, that's impossible. There must be dark matter somewhere, making them travel faster, that they're being attracted to. No. They're treating galaxies as a uniform field. So my answer would be no, it's not that Newton has to be thrown out. It's that Newton can actually stay there and that dark matter is not needed. So I understand what he's saying, but at that premise, I would say that there's a simpler answer than that. So Newton can do fine, but that's okay. I understand what he's saying. What he's saying is, okay, got to throw out Newton. But I think also the argument that it's just attractive force, basically what he should be saying is not this. This argument he should throw away. Here is how David D. Hilster is going to take Ken's ideas here and try to help him with his own logic. So I would throw that away. I would throw this away. Throw this away. This is true. What he really should be talking about is that the mechanism of the force that makes those two things together isn't, just Newton is an equation. It gives no physicality. Newton knew that. What he should be writing here is saying Newton himself knew that when you have the attraction between two masses, that he didn't have a force for it. He just has an equation that describes the result of the force. And he talked about the mundane, ultra-mundane corpuscle, gravitons. That's what they were looking at. So it seems to be somewhat of a roundabout way for him to try to explain it in some maybe more mathematical, more principled, I guess, more traditional way. But what he really should say is that Newton is not correct. Newton only, this equation right here that you guys see here, right here, this equation right there, that equation describes the result of the gravitational force. It doesn't describe what the gravitational force is. And I think that's where you should be talking about. And then I think he goes on to then talk about that. But he goes through this whole thing that it's wrong. It's not wrong. There's no mechanism there. In fact, his equations are used all the time at NASA. So the way my father and I look at this, Newton's a great step. We now have to go beyond Newton and say, Newton, we're not going to do point masses. We're not going to take every mass, the galaxy, and treat it as a point. Even the Earth and treat it as a point. The Earth's not perfectly spherical. So the gravitation, you can even see maps of the gravitation on the Earth is non-uniform. So yeah, the way I would say it is, this argument, the way he's put it together right here, that argument, it can be, it's not what he's really doing. And here's the funny part. Most of the time when I talk to people about their own theory, and this is great, I applaud him, I will support him, he can come, and but the problem is they won't get off that high horse. They're not going to say, okay, yeah, you're right. I'm proposing a new mechanism, and Newton just didn't have a mechanism. He's not wrong. Newton's not wrong. His equations work really well. In fact, we use his equations in our model to describe everything, including all the things. Just kinetic energy. Kinetic energy is 1/2 mv squared. So, you know, this argument is, it's not the best. It's going in circles. It's going in, no, it's not. It's nobody, because he's going to later on introduce okay, so the phenomenon is called gravity simply reflects vortex pressure. The fluid motion of a vortex creates a dynamic pressure. Okay, all right, he's talking about this. In what? Okay, vortex is a rotation in something. What's the something? Uh-oh. This rant is hilarious. Is that good or bad? Hey, Duplicat, tell me, is this hilarious? Because I'm off base. But this is the kind of stuff that we do when people come to our group. And this is the stuff, Radic, this is why I tell people, come to our group. Come to people who look at it. Especially a lot of us, myself, who don't have our own theory. I didn't have my own model until recently, but that wasn't even because I was looking for it. It just sort of fell together. These people can benefit from it, because this argumentation that Ken is doing here can be way better for his own good. So I'm not even arguing that ether doesn't exist. I'm not here to say, oh, ether doesn't. But I mean, just look at it. I mean, he's talking about dynamic forces of rotations in vortexes. In what? That's the first person going to say, what's rotating? Oh, the stars? You know, right now, I'm lost. And so, first of all, like I said, this argument, no. Newton's not wrong. He just didn't have a mechanism. Going through and saying, well, dark matter. Well, we know dark matter can be described by Newton and Kepler. It's just that what we have to do is, every star has this, and they all attract. Just like when we have computer programs that simulate physics, there are physical models that are put into calculations into 3D generating. So when we go to the cinema and things blow up and they look really realistic, that they have physics in there, physics in the sense of equations. And the reason they look realistic is because each particle hits each other. It used to be they all just would go out and never interact. The better models now, one piece hits another piece, and that hits another piece, that explodes. They put a lot of stuff in it. And so this needs, these equations work perfectly well, but you got to put them on every star and figure out all the different forces from all around, and you're going to find out what the overriding gravitational field is not uniform. Okay, ranking vortex model is an attempt to describe the velocity profile. I know what a vortex is, but it's in what? I'm not understanding. So there, we're talking about, okay, let's see. What kind of programming software do you do? I can answer that. Let's see here, make sure. Come on, you didn't even see his YouTube magnetism stuff. He did at least 100 videos on magnetism all. Even has okay, I get it. It's a little bit of sarcasm there. You can judge if you didn't view. Well, I'm not viewing that. I'm viewing this. And this is his website. And this is, here's his website, Magna Bay. He's got Home, Philosophy and Proposition, the falsification of the universal law of gravity. I'm reading it. And going to his videos, I don't need to because I'm reading about the scientific method. And I understand what he's saying. I'm just saying that the way he's saying it can be done better. If I were if we were at our Chappelle University of Natural Philosophy as a student, I would help him with his arguments. That's all I'm saying. So I'm not saying he's wrong. Look, I'm not saying that Ken, what's his name? Ken Wheeler? Is that his name? I'm sorry. Ken's. I'm just going to call him Ken. That Ken's wrong? I'm not even saying that. It's not like I'm not giving, some of the arguments people say, you're doing exactly what the mainstream does. You don't look at it. No, I'm looking at it. I'm looking at it. And not only that, I will tell you this. I tell people, here I'll give you another one. Ether is, gravitation is neutrinos. There's one guy from Russia who says gravity is gravitons and the neutrinos is what causes gravity. And I tell him, neutrinos don't exist. And he says, well, then I have to throw out my theory. I said, no, call it Fred theory. If your name's Fred, call it Fred particles. Why did you pick a particle that doesn't exist? So, no, Ken Wheeler, Ken Wheeler. It just came out of my mouth, so it's probably Ken Wheeler. Anyways, Ken can be totally right. All his stuff can be all right, but his arguments to get there, his arguments against what's there to get where he's at, is really muddied. It's muddled, and it's a long trip around something that's really not true. So he's saying that gravitation, because it's an attractive force, you got to throw it out. No, well, you just got to say it differently. And I'm going to beat a dead horse here. No problem. You didn't view his info. I'm not saying he's wrong. In fact, he could be right. I am here. I will say it. Write it down, make videos, send it out far and wide, and I will stand by this 1,000,000%. Ken Wheeler's model could be right. I'm not talking about that. So far, he's got a lot of problems in his logic, in my opinion, and the way he describes things. What he's doing is different. It's clear to me when I look at it and say, okay, I get it. You're just saying that you need to have some physical. What is that? Oh, I'll go look at it. I'm not looking at that right now. But what I will tell you is if he got this part wrong, I'm suspicious that they're going to be saying the same things with his own model. Then I'm going to come along and say, what about this? That's my guess. Because if you are wrong not wrong, but it's convoluted in his main arguments on his page, on one of his clicks, I'll click on another one. I can go with that. Then my guess is that those things feed into a person's logic when it comes to their model. I haven't seen it, but he could be totally right. He could have the next model. And I'm being absolutely honest about that. I don't know. But so far what I've seen, there are things that if he were in this group, these things he would have learned that the number one problem in physics is there's no physical mechanism for anything. So, what kind of programming do you do? I work with computers and human language. My friend and I, in the early 1990s, came up with a new programming language called NLP++, Natural Language Processing++. It's a computer language that makes it very easy to write computer programmers for programmers to write. So he and I came up with a programming language and an interface to quickly build these programs to be able to read text and understand it. What does that mean? It's not like speaking to something and the text comes out. It's like reading articles. If you had to read articles and pull out the information, like a database over here, you got to read articles and pull out who did what to who, when and where, what time, that kind of stuff. That's really hard to do. It makes it a lot easier if you have a programming language that's geared to kind of doing those. I got a master's in linguistics for that, so that's my computer work. Right now, I work in the supercomputing research group at LexisNexis in their HPC systems, which is their high performance computing cluster, where we can have enormous amount. The people came up with it. They can have enormous amounts of data on up to 400 blades of computer and be able to retrieve that data. So LexisNexis makes its money by selling data about information about you. We know almost everything about every person in the United States, where you've lived. So when you call up and you say, hey, I want a loan, oh, have you ever lived at one of these places? Or do you have a car? Blah, 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 blah. All that kind of stuff. So, and we can retrieve that almost instantaneously with like trillions of records, that kind of thing. So, but on my area is natural language processing. It's part of artificial intelligence area, but it's very practical. It's not like this pie in the sky stuff. Let's see. UT of view theory aphorasis. Periodic church derived the periodic table. Yeah, absolutely. Look, gosh darn it. Let me see if I can find. I'll go to my different view here. Oh, there's you can develop our periodic table if you have a model for the atom, folks. You can. So yeah, absolutely. He and other people have come up. Oh, here we go. Oh, there's what I was looking for. All right. In this book, Physics on the Fringe, she picked James Carter, who was this sort of maverick guy. I think this is him. That's an early picture of him. He was supposed to be at our conference. Where did I see his picture? Oh, here he is. And what's he standing in front of? The periodic table. Why? Because he literally has a periodic table. There it is on the back of his book. And that is his ringed. He believes that atoms are made up of rings, toroidal rings that are stable in, I guess, an ether kind of thing, because he would like smoke rings and that kind of stuff. And he has constructed, here's copper. Great system. Love it. I absolutely love it. In fact, we haven't gotten to that part of our model yet. Absolute applause. So, pretty cool. How can you criticize him if you don't read his book or view his video? Well, because I viewed his website and I viewed his logic on, okay, if I make a website and I put clicks at the very top of my website, and then I want you to read those, right? And then when I read those and I find arguments that, again, in our society where we've been outside the mainstream for a long time, that is, we know there are problems. It's not problems. Newton's isn't a problem. Newton's stuff isn't a problem. Newton's problem, it didn't solve certain things. He never solved what gravity was. In fact, he said that. He was at least, humble about it. So he said, don't ever accuse me of ever knowing what gravity really is. So how can I criticize him if I haven't seen it? I'm criticizing what I've seen. And I am saying that the way he's saying it, I would rewrite it. Because here's what would happen. We go to his website, everybody who is, a lot of people in our group, we'd all read it. He goes, oh yeah, that logic, what he's saying about why Newton's wrong, that doesn't make sense. Because Newton isn't wrong. Newton didn't propose a mechanism. And he's throwing it out because he says, well, attraction, you just can't have attraction. You got to have something there. So, and then the logic of that and dark matter. Well, we know that dark matter actually can be described by Kepler and Newton in Newtonian terms. So that argument too you can throw out because we can do that. So far, I'm saying that's my opinion about it, but it's not like I'm throwing out his whole theory. He could be right. I don't know. What am I supposed to say? That's okay. I'm sorry. Those are good questions, but those are my answers. I will go look at it. Ken Wheeler. The problem is, if you want me to do this, I will give you my honest opinion of it. And what people end up doing is get into an emotional defense of it. My father and I, we have like none, because we are the ones. I go up to him, I goes, this just can't be right. None of this, just like we are either totally crazy or this is really great. But we're the ones. If someone comes up and says, Dave, how do you make a particle stay alive for 10 billion years? Particles that are coming in waves, even if they're 5,000 kilometers apart, how does that happen? Can it, and good question. Okay, says that you haven't made one experiment. Again, I'm looking at his website. And again, I'm saying he could be right. I'm saying his logic on these pages, in my opinion, are not good. Okay? Are they wrong? It's a convoluted way, but I think it's not really what's happening. It's one, you can argue that there's a problem with Newton. Yes. You don't throw him out. No, in my opinion. But I am saying that my guess is from his model, which I haven't seen, is that the arguments that he does, that's my criticism of it. I go look at it. I can't really sit here and watch a video. I can watch a number of videos and I can come back and tell you about it. Ken Wheeler is watching you. That's fine. I have no problem. One of the things is with the CMPS, I have no qualms of a person coming up to me and talking about it. Seeing me, telling everybody I'm terrible, I don't know what I'm talking about. I am telling you, Ken Wheeler could be completely correct in his model. Just like anybody else can. Do I think his is more correct than others? I don't know. I haven't seen it. I'm just saying that the logic on this page, most of us in the CMPS would say there's a cleaner way to say this. And that's just because we've got hundreds of people have thought about this, who've gotten together. This is one of the reasons we have conferences, is because when you get together and you fight it out, and we do. I mean, we get into really heated arguments, and people end up calling people names. One guy threw coffee at another person, not even recently. That's been like 20 years ago. And, we duke it out. But in that duking out, you learn. You come back, and we've done that, and someone's come back, Dave, I thought about what you're saying. You're right. And the people who cling to their thoughts and cling to the pages they wrote, to the papers they wrote, to the videos they made. I'll show you. Look, you want to say, I'm going to show you right here, right now. Here's our book. Universe Hack 3.0, Particle Model of the Entire Universe. Okay, look at that, okay? Looks just the same, right? Nope. Look at the thickness. This is way thinner. This is thicker. Here's another book. Look at the cover. Look at the title. A no math physical model of the universe. I've got a new title now. Because we keep smashing our own theory. We keep bashing it and saying, nope, don't like it. Don't like how we explain it. The prism problem. Like this is a prism. Okay, let's say it's a prism. We shoot light into it. It comes out in a rainbow. We had 3 to 4 solutions to that with our own model in the last 2 years. And we fought over it. I would go up to my dad and say, Dad, this is wrong. There's something wrong here. My dad's first guess, he put it down. And I thought, oh, this is great. I went back to him. I said, this is wrong. That's the way you do stuff. You have to treat it like engineering. If I'm going to shoot this rocket up into space, and like NASA, I don't go and just say, we'll just our first solution's the best. No. You're going to work on it, and you're going to work on it, and you're going to smash it. You're going to find everything you can to break it. People don't do that. What they do is they fall in love with their stuff. I'm not saying Ken Wheeler's like this. I'm saying that if he's watching, or if you're watching right now, Ken, what I'm saying is when we get together, we smash on each other's stuff. And two things happen. Either you explain it to me and I get it because I was wrong, or we really find a problem that can be bettered. We can do something better in what you have. That's it. But that attitude is really rare. You're looking at one person who has no problem with that. Ken Wheeler, you can be right. If you're watching now, you could be completely right. You could have the next model for the universe that we'll use for the next 200, 300, 400 years. But on the web page, the way you describe stuff, there are better ways to do this. I would say, to be honest with you, it's being in isolation that gets you stuck in those kinds of things. When you get out, you talk about it with other people, and especially with people who look at different theories and different things all the time. But I've been looking at this since 1992, these kinds of things. I don't have the answers, but I have the attitude. I know where I got seduced by things, and it was smashed to pieces in front of me. So much so that my dad and I had the first book out. My gosh, what year? The small one. I'm sure we have the year in it. And we're still not done. We still don't like it. I came up with a new thing on the way on Thanksgiving. This is 2016. Oh, here it is. No? Oh, here it is. It's a review. Nope. We're gonna rewrite it. We're still not there. So that's what I'm saying. I think what we're hoping is we're going to go to somebody. We're going to go to somebody's website. We're going to go somewhere. Someone's going to then reveal it to us. We're all going to all bless it as yes, and the Savior is found. That's not the way it's going to work. We're getting to the point where it takes a lot more time. We don't have a model yet, and so there are a lot of competing models. And Ken Wheeler has a, I'm sure, fine model. Okay, sorry, I'm not saying anything. I'm reading. Influenced by Herbert Dingell's critique of it. Are you influenced by Herbert Dingell's critique of relativity? Yep, I've read that. But not only that, I think, in my opinion, I've read a lot of them. And actually, there's numbers of them that are very good. Pick your poison, really, which one. I think Karazani's is the most thorough, especially when it comes to special relativity. I think he nailed it in a way that really gives you an idea of really what went wrong, why it went wrong, and how to correct it. Also, you have another one. Here it is. Yeah, I'm gonna have to. Disruptive Physics: Rewriting the Rules of Physics. This is by Stephen Bryant, and he talks about relativity. This is a real technical book. He says it isn't. In my opinion, I think it is, but that one. Actually, if you want to see one really good, that actually is one of our top videos. Actually, it would be the top video. It is our top presentation video. It's my dad on special relativity. And my dad, for 10 years, he was in the movie, my movie. He was in the movie. It was mostly about him, actually, the entire movie. It turned out mostly about him because it was 9 years of filming it. And I told him at the end of the film, we had our premiere in the theater and everything, and he goes, I said, so Dad, do you believe Einstein's right or wrong? Well, I haven't really looked at it. That's a real critical thinker. He was. And guess what? He looked at it and he came up with it. So go to the youtube.naturalphilosophy.org and click on the most viewed videos. I believe that's the second most viewed video. And he has a very simple argument against special relativity. Also, when you What do you think of journals like Galilean Electrodynamics and Hyperion? They publish dissident material. Cynthia Whitney edits the former. She is our chief science officer of the CMPS. I'll go to that page. I'll show it to you. She's quite a brilliant lady, so I applaud her. I really like her work. Let's see here. There we go. Get to the directors. I love her work. It's a specific type of work. It's a specific type of. It's much more mathematically inclined, much more specified on electrodynamics, which is really looking at the field, light, all that kind of stuff. So if you're into that, that's cool. Here's the web page. So if you go to let's see, there you go. Yeah. If you go to About and CMPS Directors, you'll get that. Cynthia Whitney is the editor and publisher of Dissident Physics Journal, Galilean Electrodynamics, and Hyperion. They also, yeah. These were the places where people published a lot. We had proceedings, but they weren't. Actually, she did our proceedings, I believe. Yeah, she was the one also curating not only our proceedings, but that. And then we shifted over to Share LaTeX, which is Overleaf now, and it's an online system that allows you to have papers in LaTeX format, which is the language for printing books. And so that allows us to literally 2 weeks before the conference, we can have the last changes 2 weeks before the conference and have those print out to PDF form and put them in Lulu, and they get shipped to the conference. So we'll literally have the hot off the presses right there. So we've moved that system. We've used that for many years now. Not many years, but the last number of years. And also I plan as a project to move her Galilean Electrodynamics to the same system. If I get like a second life. And so I ain't Ken Wheeler, but it pissed me off when people don't even try properly and just bogus info without read. Well, I've answered that question. Nothing isn't as it seems. So, anyways, I think the most important thing is no, I don't do that. So I know you're accusing me of that, but I am not saying that. I don't know. I've said it 1,000 times. He could be totally right. So my criticism of what's on his website only gives me I imagine that maybe his theory is going to suffer a little bit too, because if he were to come to us, what a lot of people do who are really work on their theories, there's 2 types of people. They work on their theories in isolation. They say, screw the rest of the world. That's fine. But like I said, the risk of that is if you don't get it in circulation, you don't take the criticisms, you don't, and I'm not saying he's wrong or right, but I'm saying that because of what I saw on his website, I'm getting a feeling that maybe his theory is going to suffer from some of the brittleness of not circulating it with other people and letting them give the input. It could be really good too. I could be totally wrong. So will I do that? I don't know. Okay, because there's a lot of theories out there, and that's, I appreciate it. I will think about it. I'll take a look. I'll take a look at it. How about I do this? I'll take a look at them, and the next, because in this live video is something that I can do it then. But to make a video of that, I don't like. The reason is because it gets back to what I was saying before, and that is, right now, because we don't have a good model of the universe, there are many people working on it. And Ken Wheeler, I applaud him 1,000%. I will stand by him next to him and defend everything he's doing, because we need to support each other and new models. Dr. Alexander Unsker said it very well. Let's all continue to work on our own models. One of them is going to come going to be better than the others. One of them probably eventually be chosen. And I am writing an article on science. Well, I've got a title there. But the idea of this article will be the next big model of the universe is going to be chosen by the people. Because today, those models that are out there, we're going to have numbers of them. They're going to be described, and people are going to find them useful or not. And it will not be academia that's going to be choosing it. But that's my opinion. Okay. Alrighty. Oh, there's my daughter's listening in. All right. But I will, if you want to see my movie, send me an email, david@dissidentscience.com, david@dissidentscience.com. I will give you, if you are a person here, I will, and say your name, because I know the names that I see here. If you're interested in seeing that for free online, I'll give you a coupon to see that. Why do I charge for it? Because it pays for the service. I get enough money to pay for the service, which is a couple $100 to have a Vimeo professional account, so that you can keep it there and people can watch it. Because I think it at least deserves to be a movie and not just put it on YouTube for free. I think it is a movie that was well produced. I had some great editors from in the LA area who are very good in TV and film, and I had a great composer, all original music. And so between the editing, the story, the whole storyline, I didn't even come up with the storyline myself. I had really good people do it, so that's why. But let me know. Let's see here. Where's free book? Okay. I suggested he chat to Dave sometime. Well, that's the other thing. I am totally open always to talk with people. Most of the time, they're not going to talk to me. I was getting back to it. Here's why I don't on my channel go through and do my real analysis. Here's what's going to happen. Let's take this, okay? My goal is, when I get a book like this, is to support this guy. Okay, whether you like his stuff or not, whether you think this guy's crazy or not, he is out there. Look, relativity, really? This is someone who's trying to fix the problem. We know Einstein's wrong. We know it. We have, his model falls apart all over the place. And why is he out there? Because people cling to it. They hear it all the time. They like his crazy hair. But if you go and you look at the ping theory, look up dissident science and the ping theory, you're going to see in a very nice video. Whoops. Frozen. Oops. I froze up for a minute there. But you're going to see a very nice video of me talking about this book. And I'm very praising. I praise him the entire time. But when I look at this as sort of like, okay, it's a difference between having your kids sing in the choir, in the chorus at your elementary school, and they're singing, and you say, "Oh, Johnny, they're all so good." You praise them because you want to encourage them. They may not be the best one. They may have problems. They may sing out of tune, but you get to them and say, what's good about it? Why? Because this person needs support. Why? Because he can't go to a university. If this guy in his older age says, "I want to go and get a physics degree at whatever university," and you go to the physics department and say, "I want to show relativity wrong," they're not going to let you do it. That's ridiculous. We should allow them to do it. So what do we have to do? We have to support each other. It's like any struggle. And the funny thing is that most people outside the mainstream, most people who are not in the theoretical side of physics and all that, they are totally fine with the idea that it could be wrong. But a lot of people want the answer. They're not comfortable with there's going to be 100 models out there until one of them really pops. But that's where we are. We can say, oh, we don't like it. But there's two ways we can treat this. We can support each other, or we not. Now, this is different. Like, so when I tell you your daughter or your son sings really well, and yeah, they're a little off key and all that stuff, but then I take my own daughter and I take her to a really great top level vocal teacher, and she still has a lot to learn. She can do it. I know she can get there. She's got an incredible talent. She can go to the sky. But she's going to be told where she needs to be helped. Now, she has two ways that she can treat that. She can just think she knows it all and says, screw you, I'm just going to continue doing what I want. And probably not get as far as they can. Because today and age, people who are not as talented can work harder and get further than you. Or she can say, no, I love it. I've got a really natural talent. Imagine if I go up there. That's what Ken Wheeler, if it's the case that if he wants me, if I were to take this guy and say, I'm going to tell you what I really think of this. I can go through this and tell you where I think the logic needs a lot of work or some work or whatever. I'm not going to say. So when it comes, if you want me to go to Ken Wheeler and look at his videos, and I can do one on Ken Wheeler, and if I do it for my web, for Dissident Science, I'm going to do it because I want to support him. Because, my goodness, I'm serious. I admire everyone who's out there trying to go against big science, who won't let anybody change. They got terrible. They're models like unicorn. It's worse than Harry Potter world. Harry Potter's all made up. Harry Potter's more logical than the standard model in particle physics. But if I go through myself and I'm working on my book and my model with my father, and then I take this model next to it, I read this, I admire it, I support him, I will support him 100%. I'll help him if he wants help. But inside me, in me, I'm going to say, okay, this suffers from this. I've seen it before in other people who are isolated in their work. And if this person were to come to our conferences, they wouldn't learn that. Maybe. Can't even guarantee that. So yeah, I can look at Ken's stuff. And if you want, I think that's giving me an idea of what maybe these, what I can do on these. Maybe that's what I need to do. Maybe I'll be the hard taskmaster on my live feeds, whereas on my other feeds, I'm going to say to everybody, hey, everybody gets to be looked at. And I'm going to go through and what I did with this page. I don't do that with dissidents very often. But I think one of the problems is people want me to praise them or you want to justify it. So you say, I've read this, I like his logic. But remember, I've been in it for 22 years. I've heard the arguments. I hit my head in the same places. I looked at it. I can now step back and say, no, the real problem's this. And I can tell you why Ken Wheeler's argument on that one page, I would rewrite the whole thing. In fact, if I were to write an article about it, that's what I would say. Despite him reading this is really what's happening. I love his model, but his argument of why Newton be thrown away, you throw that out. But it doesn't change his model. That's the funny thing, folks. People will back retrofit. They'll come up with the model, and then they'll start to try to figure out why certain things are, and then they'll backpedal and try to come up with, okay, this is why they literally step out logically to say why. Why are you doing your model? Because they'll get this question. Why are you doing your model? Well, I'm doing my model because everything's wrong and we need a new model. Oh, okay, I get it. And then they go back and say, well, now I've got to, like Aetherius. Oh, now I've got to describe gravity. Oh, now I've got to describe magnetism. And magnetism, again, Unel-Denou effect. Okay, I get that. Magnetism is flows of particles. Okay, that's easy. It's flowing particles. Flowing ether in this case, which is ether is particles. Somebody's right about that. So, the array of forces. I don't know. Is that another one? I doubt it. They love photoscience. He does it because people request it. He is good. but people aren't fluent in reductive analysis. Let's see here. Is that because he's talking about theory of aphosis? So is aphosis a person or something? I'm a little lost there. Anyways, yeah. So it's 10:36. I've been going on for over 2 hours, and people in the beginning are not going to hear it, and they're going to be going away. So I'll probably have a lot less people watch this in the recording, because a lot of times but I think sometimes though they'll go ahead of it, because if they see it go on for an hour, they're not going to think I'm talking for an hour. Logic. Okay, to sum it up, it's sort of interesting that this was something I wanted to talk about. I don't know. Like I said, there's a lot of infighting. There's a lot of, Dave, look at this. I want you to verify that I like this stuff and verify it for me that it's right. No. I will verify, first of all, that you're looking at it. Applause. I'll verify, like Electric Universe, people are creating lots of people to think outside the box. Lots and lots and lots of them. Applause. I will support them, again, to the nth degree. Ken Wheeler, applause. Everybody who has their own theory, applause. And therefore, I don't need to sit there and tell you what I think's wrong with them. Now, I can do that, and like I said, maybe I think in these, I don't know though, because I'm only going to create enemies. And that's not my purpose. I think the only thing I can say over and 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 over again is circulate. If you're a person that's working on your own stuff, if you don't want criticism, and if you don't want someone to steal the best parts and do something better, I'm not going to say that my dad and I have done that, but if you got me in a corner and I would tell you with truth serum, yep, we took some really good ideas and made them better. And those people are stuck, in my opinion. Now, that's my opinion. I could be completely wrong on this. And that's the difference between me and a lot of other people. Other people are right. I'm fascinated because our model's working really well. And it's so simple, and my dad and I don't know why. We're trying to come up with why. But doesn't matter. He and I will turn to you. We're the first people to say that we're wrong. And I'm the first person to say that any one of the theories out there, including this guy and the ping theory, I can't say they're wrong. I can say that there's some, according to us looking at the problems in physics today and the models today, we've got a lot of bad stuff out there to be able to analyze and find out. It'd be like giving rocket scientists the data for 50 launches that didn't work, and you don't think they'd learn some things about what not to do and what to do? Well, that's the kind of analogy we have. People who go to our conference and duke it out are going to be better. I'll give you an example as the expanding Earth. If you have a theory and you can't explain why mass is increasing in the Earth, and that's at a subatomic level, at the atomic level, subatomic level, then, according to most people outside the mainstream, then your theory is missing something. That's a good example. Okay, any more? Let's see. Dave was looking at an article about Ken. Okay, I suggested he make field bifocals, but he said his stuff works for near field only. Disappointing because his stuff shows a whole new world. Well, anyways, yeah, I'm sure Ken must be an interesting dude. So, I see. I can do show. Okay, show. There we go. All right. Sorry about that, folks. I didn't know how to use it. Oh, here's show. Oh, I see. People can do links, and I'm not showing them. Hey, there's 9 people here still. We've talked a lot about Ken. I can take a few more questions, but I'm going to get going pretty soon. Dissident science. Have any scientists explain this? I wonder if I can go to that. Hold on. Oh, I can go to those links. I'm sorry, I'm going to a link right now. I'm looking at the chats on my phone. Probably a better way, but this way I don't get into the computing power of my computer, which is running a number of things here. Scientists slow the speed of light. So, oh, I've seen this. I think I did check my channel. I may have talked about this. They sent photons, individual light, through a special mask. It changed photon shape and slowed them to less than the speed of light. The photon remained traveling in a lower speed even when they returned to free space. You just want to shoot me now, or should I say it? Depends on what model you're talking about. That's the answer. In fact, our particle model can explain this, because particle model will explain this. But it's a wave. It's a particle. It's a wave particle. It's wave particle duality. So, again, what I would say the answer to this, and I'm sorry about that. I don't want to be trite about this. So sorry. Oh, I've got to go back? Oh, that's weird. Done. Okay. I'm sorry about that. That was Illuminati Socrates. Yeah, just depend on your model. So pick your model and then see if it explains it. If you are writing a model, like Ken Wheeler or somebody, explain it. And that's what my father and I always do. Every time something comes new, we try to explain it if it's on our lists of stuff. Dave was looking at, okay, I suggested he make, okay, where do you recommend people start to learn physics for people with relatively little knowledge in mathematics? I have a YouTube for the beginner. Let's see if I can find that. Okay, I'll be right with you there, Rolanda. I'm going to be going very soon here, but let me find that for you. I have a video for that. So if I look it up, it's really going to be slow. Anyways, start here for newbies. Let's see, Dissident Science newbies. I wonder if I did that. Yeah. So what you do is you go to Dissident Science Newbies, type in Dissident Science Newbies, and you'll get Science Woke Newbies, where to start. The truth of the matter, where to start will be sciencewoke.org when we get that out. That'll be the place to go. And if you want to help out with it, you can. I'm going to be starting a Patreon for our members, actually, because our members can't write articles that average person can understand. All of them can't. So I can, but other people have a harder time with it. So I'm going to put up a Patreon. It's going to be $50 for every article that we write, and we'll get either writers to do it or myself. Time is money because I can't justify this. But anyways, start there. 4 months ago, 273 views is all. Well, take a look at that. But yeah, Science Woke will be that okay. It's a wavicle. I like that. Dave, you can't read one half of a comment to grasp its intent. Duplicate. Well, where are we then? Dave was looking at the the rest of the main links from the man. Okay. I'm not sure what you mean by that, duplicate. But anyways, I'm going to get going. Thank you so much. I appreciate it. I really do. I know that that people continue to come here. I will think about the idea of trying to go through somebody like Ken Wheeler and really give you my real truthful answer to it, the way I would talk to my dad. I'm not sure. I need to know how to couch that because, again, I support Ken and everybody who works on this. I don't want it to be to seem really, really negative. It could end up seeming that way. I got to come up with a way to do this in a positive way. And just like I said with logic there, Ken Wheeler's, I'm sure, work doesn't change because of his logic, his what I call back logic of trying to justify why throwing something else out. I mean, you can get all that wrong. Who cares? But it's like, I'm using neutrino. Call it something else. There's no neutrinos. I can't get the guy to change. It's like, if you renamed the particle, would your model change? No. But no, he actually says, yes, it would. I said, well, why? Well, because I said, well, use the same properties. Just don't call it a neutrino. They don't exist. So, but anyways, I'm going to think about going through that and doing it during these sessions, because maybe that will make these sessions more interesting, maybe for the hardcore people, because the average Joe is going to not necessarily sit through almost 2 hours of this. But thank you very much for everybody's support. It's greatly, greatly, greatly appreciated. I'm not here to push my theory that it's the best. I have a theory my dad and I are working on. I'm here to try to get you guys to have a right attitude towards science, and that is, even if you find something you like, it's not yours, don't marry it. Don't become emotionally attached to it. We're lucky, as my father says, to cobble together any types of equation to do anything useful at all. The universe isn't complex. It's not crazy. It's not strange. Our interpretations of it are, and they only can get better, and they need to be simpler. So thank you so much again for your support. Let other people know. I mean, the subscribers, again, they got rid of a lot of dead subscribers out there. I don't know, not really dead ones, but so I know my subscriber fell quite a bit, but a lot of people's have. There's a lot of spam subscribers out there. But I think recently we've got, I've been getting a lot more because people have been pointing my way negatively, but they stick. Thank you so much. And if you do have a topic or something, come on our Friday nights and I'll talk about it just like we did. And Ken Wheeler, thank you so much for your work. Continue working. That's the key. You don't have to listen to me. You don't have to care about me. But I think it's always good to have other people bash on your stuff a little bit, pound it out, battle it around, give you some feedback, duke it out, because that's the best. And I recommend every one of you who likes this, if you can, University of Washington next year in the late June 26th through 29th at the University of Washington. It's cheap. Our conference is cheap. And the accommodations are cheap. I think it's like $40 or $45 a day or $50 a day is all. And you're going to have the greatest time. You're going to be with people that are really brilliant who will duke it out. And that you won't see me, but maybe you will see it on my live stuff. Okay? Alrighty. Take care. And I will sign off. I always put my name. This is Dave. No, I have to sign off. Stay critical. Stay thinking. I am David D. Hilster, your science therapist, trying to get you to the promised land of being science woke. That is it, folks. Yep, still working on sciencewoke.org. Ciao for now.